Today we'll be discussing about another typical type of problem that we get from the Routh criteria, that is to find the value of gain for the system stability. So this is the open loop transfer function which is given. For the Routh criteria, we definitely need the equation, that is the characteristic equation we need. So for the characteristic equation, what do we have to do? We need to do there is the open loop transfer function, that is this is GSHS. So we need to find out 1 plus GSHS. So just we need to do a 1 plus, and then we need to consider the upper part only, because this is GS. So 1 plus, so GS by 1 plus GSHS and the lower part only. That would give me, that is S into S square plus S plus 1 into S plus 4 plus K, that is equal to 0. If you were not able to understand why this has come, this is just because this is G and the transfer function is G by 1 plus GH, and normally we take a unity negative feedback, so this is 1 plus GS. Please watch my previous videos to understand how this formula has come into being. Okay, so now from this we can directly make out our new characteristic equation, that is S cube plus S square plus S into S plus 4 plus K equals 0, or that is my S to the power 4 plus 3S square plus 4S square plus S square, that is plus 5S square plus S cube, plus we get it as 4S square plus S square, that is my 5S square again, plus 4S plus K, which is equal to 0. We get this now directly going on my Routh criteria, S to the power 4, S cube, S square, S to the power 1 and S to the power 0. We get it as 1, 5 and K. As we know, this would be my 5, S, 4 and 0. Now for the next, we know this into this minus this into this, so this will be 25 minus 4, that is my 21 by 5, right? This will be 500 K by 5, that would be K. This would be 21 by 5 into 4, that is my 84 by 5, 84 by 5 minus 5K by 21 by 5. Then this would be definitely a 0, and the last would definitely be a K, right? So moving on with this one, we need to find out the values of K for which the system is stable. So what do we know? We know that this row should be all positive for the system to be stable. So the first criteria for stability would definitely be that K should be greater than 0. That is the first criteria of stability. What will be the next criteria of stability? It would be that this whole thing would be greater than 0. That is 84 by 5. 84 by 5 minus of 5K should be greater than 0, right? Or 84 by 5 should be greater than 5K, or my K should be less than 84 by 25. So we find out that the stability criteria is 0 to K to 84 by 25, right? So this is one question. Now I can say that if I put K is equal to 84 by 25, we get this whole thing as 0. Another question is asked. In such a condition, it is called marginal stability, and we need to find out the fundamental frequency of oscillation at that time. So at 84 by 25 value of K, this whole becomes 0. So what will be the auxiliary equation? Auxiliary equation will be this thing, and the roots of the auxiliary equation will give us the fundamental frequency, right? So let us do it. Let us solve it. So 21 by 5 into S square plus 84 by 25 will be equal to 0, right? So my value, so just cut it, is 5, 4, so S square plus 4 by 5 equals 0, or S square equal to minus 4 by 5, or S is equal to plus minus 2 by root 5 into G. Is equal to plus minus 2 by root 5 into G. So this is my fundamental frequency where omega is equal to 2 by root 5. Obviously the unit is radian per second. That is how we can find out the fundamental frequency of oscillation in such a type of a Routh-Hurwitz problem. Thank you for watching. In the next video we'll be proceeding to root locus. Thank you.